Good morning, Rich Nass with Embedded Computing Design, and we are continuing our series of trends in the embedded industry. I'm here at Red Pine Signals. I'm with Venkat Matella. He is the founder and CEO of Red Pine. Good morning, Venkat.
Good morning, Rich.
You guys do IoT MCUs and in addition to lots of other stuff I know, but I'd like to talk about that subject today. One of the things I saw from a recent announcement that you made was you're putting a lot more stuff into an MCU than would be typically found. It's a dual core MCU, there's a DSP, there's some security, there's a lot of analog and power. What does that mean from a developer's perspective? Is it a lot harder to develop an end device than it was a year or two ago?
Well, again, to start with, Rich, that we want to look at in terms of what are the requirements for a so-called IoT MCU. And everybody talks about an MCU. By definition, MCU is a resource-constrained computing system, and it was designed to address certain control applications in the past. However, when the IoT evolved from a regular Internet of Things to intelligent processing at the node, certain requirements came up. For example, if you take a smart and secure device, you need to do the wireless connectivity is a must-have, and you need to have the intelligent computing on the same node, as well as scaling between the low power and high performance.
So I'll stop you here. You're making the determination on which wireless somebody should use?
No, absolutely not. Internet of Things device by definition means it needs to have a connectivity. If you remove the connectivity, there is no IoT.
Of course.
So that's why, because connectivity is a must, how do you support a connectivity in IoT node? That means support basically means that you need to take the wireless packets and infer what exactly the communication being communicated through that. So that requires the processing system to be designed differently than what it used to be for doing a sensor data collection, which is coming very infrequently. So that's where the real requirements for IoT MCU are different than the regular MCUs, which people have been doing for the last few decades.
Okay, so let's circle back to the software side of this. With all the stuff that you're putting in there, does today's developer have the tools that he needs to write the code for a pretty complex MCU?
Yes, in fact, that's a very good question, because at the end of the day, the requirements always will be there based on how the market is evolving. But if the developer do not have the right tools, it's not going to be optimal. So I would say that the tool industry is very matured as far as the microcontroller parts are concerned. However, they are still designed for a single thread. They're still designed for a very sophisticated microcontroller architecture in their existing definition. However, then the market requires security, intelligence, wireless enabled, and obviously those tools are not 100% geared for that. So our job is to innovate at the microarchitecture level so that the same tools work seamlessly for the developer. If I build multiple processing cores like security, intelligence, wireless interface processing, and you have to use 4 different tools, it does not serve the purpose. So what we have done is providing the light libraries, right innovation at the IC level, so that the existing tool chain works for the given application seamlessly. So that's what our innovation in the smart MCU family.
Okay, so let's go into the crystal ball a little bit. Let's go out, 18 months is probably fair. It's about as far out as we can see. Will we see more cores or higher performance cores? Where do we go from there? Because I don't think we don't want to grow the die size.
Yes.
So what will be next? And I'm not talking about Red Pine specifically.
Sure.
In the industry,
I think let's look at in terms of the very generically what would be a requirement for a smart and a secured IoT device. Let's start from there. So as I mentioned that any secure or a smart device, IoT device, that means communication is a must. Without communication, there's no IoT. So how do you provide a communication? If you take a technology like a Wi-Fi technology, it's a networking technology. What that basically means is that there is a huge amount of software stack that has to be run on the network processor. However, microcontrollers are not network processors. They're microcontroller units. So now how do you communicate, how do you support a wireless networking technology and a resource-constrained microcontroller is a challenge. And that's where we need to have the microarchitecture or the chip design or a microcontroller design different than what microcontroller vendors are known for all these years. And it's not a small difference, it's a very significant difference, because you need to bring in the networking technology into a microcontroller world. So that's where the first thing that we would say is that there would be a network processor architecture that will be embedded along with the microcontroller, which is not understood to date. The very first approach, the very first offering in the industry is the Smart MCU family. You can look at all the tier 1 microcontroller vendors, all their 20, 30 product families. There's no understanding or the appreciation of the networking technology embedding inside the microcontroller architecture. That's the number one. The number two is, of course, the performance. We call it power performance scaling. That's where we have patents for using this gear shifting architecture. What this basically means is, in the IoT world, you need to have an ultra low power. You need to work for months, years. At the same time, you want to do some intelligent job. It's not counting step counts. That is not really an intelligent job. But you wake up and you do some heart rate monitoring and infer certain things, run a model. Those kind of things require a huge processing power. But at the same time, I don't want to charge every day. I want to use it for 2 years. So what that basically means is that you need an architecture which can go to ultra low power. It can do high performance. And that's one of the critical requirements for smart devices going forward. And the third, of course, is the most important, is the security aspect, right, which is every application has a different level of security requirement depending on what service it provides, what application it runs. And we have used our expertise or what is happening in the industry in the trusted execution environment, brought in all those micro architectures and brought into a unified smart MCU architecture, which we believe that is the critical piece of any future IoT device design.
Okay. Yep. Real quick, just to wrap up. Some of these things you mentioned and fall in the same category for me, both the security and the power. You're leading the, I don't want to screw up this analogy, but you're offering the tools. How do you make sure that they use those tools?
Well, I think we cannot expose it to a level where a developer needs to know the details, and that's where our value comes in. So that means if somebody is using a wireless connectivity on an IoT device, you should not give him a lot of 100 commands to run. You just use it in a generic way. It should be the lowest power. So that's where, if you look at our 17 years of R&D and product development in the IoT space, we do nothing but low power. When I say the connectivity, microprocessing, security processing, intelligent processing, all these things people can do. If you put a lot of money, a lot of processing can be done. Can you do it in the ultra low power? And that's where we research.
Very good. Thank you very much.
Thank you, sir.